Hey guys, today we drift into something so familiar that you rarely even notice it. Yet it shapes every breath you take, every step you make, and even the quiet rhythm of your heartbeat. Tonight, we're sinking gently into the soft, invisible pull of gravity, the force that hugs you to the world even while you sleep. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're settling in, feel free to tell me where you're listening from and what time of night it is for you. Wherever you are, let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. You're here, lying still, feeling the softness beneath you, and without realizing it, you're also feeling the earth gently pulling you toward its center. That pull is happening every single moment. Even now, a steady, unwavering embrace that you never have to think about. If you close your eyes for a moment, you might imagine your body sinking a few millimeters into the mattress, not actually moving, but simply being held, as though the planet itself were cradling you. The truth is, that is happening. Your weight is nothing more than gravity, gently saying, "Stay close. I've got you." As you breathe in, you may notice a tiny sensation in your chest, a lift that feels effortless. But that effortlessness is an illusion. If gravity suddenly disappeared, even for a fraction of a second, the air in your lungs would billow outward, your body fluids would start drifting upward, and you would no longer feel attached to the bed or to anything at all. Gravity gives shape to every movement you make, from the blink of an eye to the stretch of a finger. What's strangely comforting is that scientists still don't fully understand what gravity actually is. You might imagine they've solved it by now. After all, we've been studying this force for thousands of years. Ancient astronomers noticed that apples fall, planets orbit, comets arc gracefully through the sky, and everything obeys a kind of quiet, cosmic choreography. But even today, with all our technology, with space telescopes and particle accelerators and precise atomic clocks, we're still trying to understand the true nature of this force that's holding you in place right this second. As you rest here, imagine that gravity isn't a force pulling down, but a gentle curve in the world beneath you. You're lying on a fabric, the fabric of space and time, and the earth creates a small indentation in that fabric, like a heavy marble resting on a soft sheet. You roll toward the indentation, not because something is grabbing you, but because the sheet itself is curving. Right now, you're not being pulled to the earth. You're sliding toward its curve, softly, constantly, gracefully. That idea alone can shift the way your body feels, grounded, anchored, safe. But here's a little odd truth for you, and one that most people never realize. Gravity is so weak that a simple refrigerator magnet can overpower the entire Earth. If you've ever lifted a paperclip using just a tiny magnet, you were witnessing one of the strangest facts in physics. Your magnet, small, cheap, barely noticeable, was defeating the gravitational pull of the entire planet. Think about how absurdly weak gravity must be for that to happen. This whisper of a force somehow manages to shape planets, guide moons, sculpt galaxies, and hold your body in place. It's fragile and mighty at the same time. And here's where scientists start to disagree, even today. Some still argue that gravity is a fundamental force like electromagnetism or the strong nuclear force. But others believe gravity isn't a force at all. It's simply geometry, a curve, a shape, a bending of something deeper. And some believe it may be an emergent phenomenon, something that appears only when matter and energy get arranged in certain ways. Almost like gravity is a side effect of existence. This debate touches you, even though you don't feel the debate happening. But it's there, in the invisible structure of the room around you, in the downward pull on your feet, in the way the air settles into the space in front of your chest as you inhale. Every moment of your life is lived inside this unanswered question. And while you lie there, you might imagine the earth below you not as a solid sphere, but as a quiet engine of gravity, humming beneath the crust. Thousands of trillions of tons of rock and metal, slowly spinning, gently tugging at you, holding oceans in place, shaping the atmosphere, guiding the moon's orbit. That's the strange and soothing part. Gravity never sleeps. It acts on you 24 hours a day, asking nothing in return. If you could float just a few meters upward, nothing would change. But float a few 100 kilometers upward, and you'd begin to sense a slight lightness. Float further, 1,000 kilometers or so, and the curve of the earth would sharpen in your view. At that altitude, you might think you would feel weightless, but you wouldn't. Not really. You'd only feel weightless if you were falling. Falling in such a perfect sideways motion that you keep missing the earth over and over. That's what astronauts experience. They aren't free from gravity. They're dancing with it. And right now, you're doing the opposite. You're resting in gravity's arms. You're letting it hold you still while your heart beats slow. And whether you realize it or not, this moment, this quiet, still moment, is only possible because gravity exists. Somewhere, miles beneath your feet, the Earth's core is spinning like a molten engine. Above you, the moon is pulling on the oceans, inch by inch. And all around you, the air is pressed close to the surface of the world because gravity is hugging it too. You're not alone in this invisible embrace. Everything around you, the room, the bed, the pillow beneath your head, is part of this gentle, universal motion. Tonight, you're simply noticing it. You're gently sinking deeper into the quiet now, letting the room fade around you as you follow this strange, soothing idea, falling without falling. It sounds impossible at first. You might picture a person tumbling through the sky, spinning, flailing, terrified. But what astronauts experience isn't that kind of fall. It's something much more peaceful, a continuous, endless drift where the ground never arrives. And somehow, this gentle paradox begins with the same gravity that's holding you in place at this very moment. You can imagine yourself rising slowly, lifting away from the mattress, drifting toward the ceiling, except nothing in the room changes. Not the temperature, not the air, not the hum of the night around you. You simply float, like a soft balloon escaping someone's hand. But in space, floating isn't about rising. It's about moving sideways fast enough that you're always missing the Earth. The moment you're in orbit, gravity doesn't disappear. It just becomes the quiet companion that guides you along a perfect curve. The next time you see a video of astronauts drifting through the International Space Station, gently pushing off a wall and gliding through the air like silk, remember, they're not free from gravity. They're falling. The entire station is falling around Earth at just the right speed so that it never hits the ground. And the astronauts inside are falling with it. But because they're all falling together, there's no sensation of weight. It's like being inside an elevator that never stops descending, except the floor is moving away from you at exactly the same rate. If you close your eyes, you might picture what that feels like. No pressure on your back, no weight in your limbs, no part of you being pressed downward. You'd feel like a thought, drifting freely through a silent, glowing world. Every direction becomes up, and every direction becomes down. Nothing holds you. Nothing pushes you. You would only move when you choose to, and even the smallest motion sends you floating gently across the room. What's strange, and almost poetic, is that the human body actually struggles with this dreamy weightlessness. In the first few days, your face puffs up as fluids drift toward your head. Your spine stretches. You grow a little taller. Your eyes change shape because of the pressure, and your sense of balance collapses because your inner ears were built for a world where down always pointed toward the center of the earth. Without gravity telling them which way is which, they begin to guess, and guess wrong. It turns out that your brain depends on gravity far more than you think. It needs that downward pull to know what's real, what's stable, what's safe. Without it, your mind floats too. Some astronauts describe a moment, usually in the first day or two, where they wake from sleep and can't tell which direction they're facing. They don't feel upside down or sideways. They feel directionless. The world becomes a soft sphere instead of a floor-and sky reality. And for a brief moment, they understand how deeply gravity shapes perception. But there's a hidden detail, a little-known fact, that makes the experience even stranger. Astronauts don't actually sleep very well in microgravity. They float into their sleeping bags, zip themselves to a wall so they don't drift away, and try to relax. But without pressure, without the sensation of their body resting on something, their brains interpret the environment as not safe. Humans evolved to sleep when we're grounded. We fall asleep best when gravity tells us, lie down, be still, the world isn't moving. And that's why, right now, lying in your bed, you're actually in the ideal environment for sleep. Your body recognizes this moment. It feels the pull, the stability, the anchoredness. You are supported, held, and oriented. All of your internal senses, balance, pressure, perception, are telling you everything is okay. But there's another twist to this story, one that scientists still debate. Some researchers argue that astronauts in low Earth orbit aren't really experiencing true weightlessness at all. Their bodies are in a state that physicists call microgravity. But microgravity isn't the absence of gravity. It's simply gravity that's being partially canceled by inertial motion, the sideways fall of the spacecraft. Others argue that this doesn't matter, because the internal experience is the same, no weight. But another group of scientists disagrees, claiming that the term zero gravity is misleading and has confused the public for years. It's one of those debates where each side is correct and incorrect in different ways. Gravity is complicated like that. It refuses to fit neatly into language. If you imagine yourself drifting above Earth, letting your fingers trail lightly through the air, you can almost feel how surreal this environment is. Outside the window, the planet curves beneath you, glowing blue and white. You circle it every 90 minutes, sunrise, sunset, sunrise, sunset, a rhythm that would confuse your internal clock until you lose all sense of day and night. But even up there, at 400 kilometers above the surface, gravity is still about 90% as strong as it is right now, where you're lying. If the station stopped moving sideways, you would drop toward the Earth instantly, accelerating just like a falling stone. The only difference is motion, constant, careful, precise motion, balancing you on the edge of a fall that never ends. Isn't it strange that falling, something we fear so deeply, becomes something peaceful in space? Instead of panic, it becomes a glide. Instead of danger, it becomes freedom, falling without falling, held by gravity, free by motion. And here you are, grounded, still, safe, but somehow connected to that same force. You're not orbiting, but you're participating in the same dance. You're resting in the same curve of the Earth that guides the station. And as the night deepens around you, that soft pull becomes something almost comforting. You're not drifting. You're not falling. You're simply here, cradled by the quiet weight of the world. You're drifting deeper now, letting your mind soften as the night wraps gently around you. And as you settle, you begin to sense something even smaller, quieter, and stranger than anything we've touched so far: gravity at the scale of atoms. It's easy to think of gravity as a force that only matters for big things: planets, moons, oceans, mountains. But tonight, you're shrinking your attention down to the tiniest details of existence, and you'll discover something beautifully peculiar. Gravity is almost irrelevant inside the atom. Yet without it, the universe as you know it simply wouldn't make sense. You might picture an atom like a miniature solar system, electrons orbiting like tiny planets around a dense nucleus. But the truth is far stranger. Electrons don't orbit in neat paths. They exist as smeared out clouds of probability, shimmering in and out of specific locations. The nucleus itself is a turbulent cluster of protons and neutrons held together by the strongest force nature has ever invented. The strong nuclear force, a force so powerful that it overwhelms gravity by a factor so large it's almost impossible to visualize. If you could shrink yourself down to the scale of a proton, a space so tiny that a grain of dust would feel like an entire galaxy, you'd find that gravity has almost no influence there. A grain of sand has more gravitational pull than an entire atom. And yet, without gravity shaping the larger structures of the universe, the atoms themselves would never have come together in the first place. Stars would never have formed. Nuclear fusion would never have ignited. The atoms inside your body, carbon, oxygen, nitrogen, calcium, would never exist at all. Here in this quiet room, while the night settles and your breath slows, you're made of matter that was once forged in the hearts of collapsing stars. And those stars collapsed because gravity squeezed them until their cores ignited with unimaginable heat and pressure. Even though gravity is so weak it barely matters inside an atom, it becomes the engine that creates atoms in the first place. It's like the universe uses gravity as a cosmic architect, one that works slowly, gently, tirelessly across billions of years. And here's a detail that almost no one knows. Inside your body, every atom is still slightly influenced by gravity. It's unbelievably tiny, but when you lie down, the atoms in your bones settle differently than when you stand or when you float in water. Your entire body subtly shifts at the atomic level, not enough for you to notice, but enough to show up in a sensitive experiment. Your atoms lean toward the earth. Mine do too. Every molecule in your blood is gently tilted toward the center of the planet. But this leads to a question that scientists are still arguing about. A question that lives at the crossroads of quantum mechanics and general relativity. Does gravity behave the same way at quantum scales as it does at human scales? Some physicists say yes. Gravity is continuous, smooth, elegant, and universal. It curves space, and everything in that space, even atoms, must obey the curve. Others disagree fiercely, arguing that gravity must break down into quantized packets called gravitons, tiny particles that transmit the gravitational interaction the way photons handle light. If gravitons exist, then gravity, at the smallest scale, behaves like a flicker, a vibration, a graininess too fine for us to detect. This isn't a small disagreement. It's one of the biggest unsolved problems in modern physics, the clash between Einstein's general relativity, which explains big things like galaxies, and quantum mechanics, which explains small things like atoms. These two frameworks are both brilliant, both proven, and both incompatible. It's as if the universe has two instruction manuals that don't match. As you lie here, resting gently in gravity's arms, your body is the meeting point of these two worlds. Your atoms follow quantum rules. Your body follows gravitational rules. And somehow, without any effort from you, these two systems cooperate perfectly, letting you breathe, think, dream. You can imagine the nucleus of an atom, a cluster of protons and neutrons, buzzing with energy. Inside that nucleus, the strong nuclear force is so intense that it can bind particles in ways gravity could never imitate. If gravity tried to hold a nucleus together, it would fail instantly. But when you zoom out, your atoms form molecules, your molecules form cells, your cells form tissues, and at that scale gravity begins to matter again. It pulls you downward, guides your posture, influences your balance. There's a strange beauty in this multi-layered relationship. Gravity creates the stars that forge the atoms. Atoms ignore gravity while holding themselves together. Then gravity returns, shaping the world those atoms eventually build. And as you think about this, the tiniest pieces of yourself, the cosmic forces above you, the quiet conversation between the microscopic and the massive, you might feel a deeper sense of connection. Every part of you is participating in a dialogue that stretches across scales. Physics isn't happening out there. It's happening inside you, around you, through you, every moment. Even the quietness you feel now, the heaviness of your eyelids, the warmth spreading through your limbs, the way your breath settles into a slower rhythm, all of it reflects atoms arranged in a universe shaped by gravity. You're not just lying in a room at night. You're resting inside a giant, invisible structure, a cosmic web held together by the same force that anchors your atoms in place. Somewhere in this vast universe, stars are collapsing, galaxies are drifting, and black holes are bending the fabric of reality. And here you are, a single, quiet observer, feeling the soft pull of the same force that governs all of it. Tonight, that connection feels gentle, and enough, and deeply peaceful. You're sinking even more deeply into the stillness now, and as the rhythm of your breath softens, you begin to sense something even stranger, even more delicate. Gravity doesn't just pull on space, it pulls on time itself. And right here, in this quiet moment, you're living inside that stretched, curved, flowing river of time without ever noticing it. Time feels simple when you're lying here in the dark. Seconds pass, steady and even. But the truth, the beautifully hidden truth, is that time is not the same everywhere. It changes depending on how strong gravity is around you. The greater the gravitational pull, the slower time flows. Not metaphorically, not poetically, literally. If you were to rise just a few meters above your bed, not in imagination, but physically, time would pass a tiny bit faster for you than for the person lying down. The difference is unimaginably small, far too small to feel, but atomic clocks can measure it. This means that your head is aging slightly faster than your feet. Every single night, as you rest, the top half of your body moves through time just a little bit differently from the bottom half. It's not enough to notice, but it happens quietly, consistently, endlessly. Einstein didn't discover this from a lab experiment or a telescope. He discovered it by thinking, imagining how light, motion, space, and gravity all dance together. He realized that gravity isn't just a force pulling inward. It's a curvature of the fabric of reality itself. When space curves downward, time curves too. Where gravity is stronger, time hesitates. Where gravity weakens, time relaxes. And here's a little piece of strangeness. If you lived your whole life on a tall mountain, you would age ever so slightly faster than someone who lived at sea level. Not enough to make a difference, maybe a tiny fraction of a second over decades, but real, measurable, and unavoidable. Even your phone uses this fact. GPS satellites orbit high above the Earth where gravity is weaker. Time passes faster for them. If their clocks weren't corrected for gravity's influence on time, your navigation apps would be wrong by kilometers. Your phone literally works because it takes Einstein seriously. Tonight, as you lie here in the dim quiet, you're also living inside that stretching and bending of time. The room around you feels still, but the seconds passing over your body flow like water over a smooth rock. Not perfectly even, but rippling ever so slightly where gravity tugs. It's comforting in a way. The universe doesn't rush. It doesn't demand that time be the same everywhere. It lets different places move at different rhythms, like quiet instruments in a cosmic orchestra. You, right now, are playing your own small rhythm, a rhythm shaped by the earth beneath you. But there's a strange detail that only a handful of people know. If you were to move toward a black hole, one of the strongest gravitational environments in the universe, time would slow dramatically for you. Minutes for you could be years for someone far away. Gravity would stretch time like taffy. And yet, if you were the one drifting near the black hole's edge, you wouldn't feel anything strange. You'd breathe the same, blink the same, feel the same. Inside your experience, time would feel perfectly normal. It always does. The bending only reveals itself when you compare your flow of time to someone else's. This leads to one of the most heated debates in physics. Is time something that exists independently, flowing on its own? Or is time something that emerges from the fabric of space when matter is present? Some scientists argue that time is fundamental, a built-in coordinate of the universe. Others believe that time is not a simple dimension, but a byproduct of deeper symmetries and quantum states. A few even suggest that time might not be real at all, but a kind of illusion created by entropy, by the gradual spreading of energy. As you lie still, that debate doesn't feel disturbing. It feels calming. Time doesn't need to be understood to be felt. You can feel it now, not as numbers on a clock, but as the slow unwinding inside your muscles, the soft weight of your limbs sinking deeper into the bed, the way your thoughts are drifting with less urgency. Gravity and time are tied together, and you're noticing their connection in the simplest way possible. When you lie down, gravity pulls evenly along your body. Your heartbeat slows. Your mind steadies. Time feels smoother. Not because the physics has changed, but because your relationship to the world has changed. Every creature on Earth, from birds in the air to fish deep in the ocean, lives inside this curved river of time. And as you drift here tonight, you're floating gently along the same current, letting gravity cradle not just your body, but the seconds that carry you towards sleep. It's almost poetic. Gravity doesn't just hold you, it shapes the tempo of your life. And in this moment, that tempo is soft, slow, and peaceful. You're drifting comfortably now, your breath warm and slow, and as the quiet wraps around you, we shift our attention to something immense yet almost imperceptible. How mountains bend gravity itself. It sounds exaggerated. Mountains are huge, yes, but could they really tug on you, even slightly, as you lie here tonight? The answer is yes. And the story behind that tiny tug is one of the most peculiar, least known chapters in the history of physics and exploration. Imagine yourself standing alone before a massive mountain range. The Himalayas, perhaps. The air is thin, the winds are cold, and the stone rises so high that its summit disappears into clouds. You look up at it and feel small, but you don't feel pulled toward it. Yet, whether you notice or not, the mountain is pulling on you. Its mass creates a gravity of its own. It's incredibly weak, far weaker than the Earth's, but it exists. Every boulder, every ridge, every buried layer of granite is tugging at your body with a force that can be measured, and researchers have measured it. You might picture a pendulum, a simple metal bob hanging from a string, gently swaying in the breeze. But if you place that pendulum on the side of a massive mountain, something odd happens. It leans ever so slightly toward the mountain, not toward the Earth's center, but sideways, drawn by the mountain's own gravitational pull. In the 18th century, scientists traveled deep into the wilderness to perform exactly this experiment. They hauled telescopes and pendulums and heavy equipment up steep slopes, all to observe a shift so tiny that only patience and genius could detect it. They discovered that the mountain caused the pendulum to deviate, just a fraction of a degree, but enough to astonish the scientific world. This tiny tilt helped them calculate Earth's density and proved something subtle and elegant. Large features on the surface of the Earth distort gravity, producing ripples in the gravitational field. Right now, even as you rest, the ground beneath you has its own invisible gravity landscape. It isn't perfectly smooth. It has hills and valleys, not just in shape but in weight. A dense rock formation deep underground might pull on you slightly more than soft, porous soil. A mountain pulls sideways. A canyon pulls a bit less. And though you'll never sense these differences, sensitive instruments pick them up like a gentle fingerprint on the planet. You can imagine the world beneath you as a map, not just of landforms, but of gravitational highs and lows. Tiny differences measured in millionths of a percent. Some scientists even describe these as gravity wrinkles, subtle distortions that echo the structure of what lies hidden beneath Earth's surface. Explorers use gravity maps to find underground caverns, ancient riverbeds, mineral deposits, even lost continents buried under the ocean floor, all by following these delicate signatures in Earth's gravitational field. And here's one of those little-known curiosities. If you were to climb a tall mountain, your weight would drop, not just because you're farther from the center of the Earth, but because the mountain itself contributes less mass beneath you. Ironically, the higher you go, the less gravity you feel, and the lighter your body becomes. Not enough to notice, but enough to measure. This leads to a small but fascinating debate among geophysicists. Should we think of mountains as places where gravity is distorted, or as places where gravity simply reflects local variations in mass? Some argue that distortion implies something exotic or unusual, when really it's just physics doing what physics always does when mass is present. Others insist that the word distortion is appropriate because gravity maps do look distorted, rippled, warped, like a blanket pulled unevenly over bumps. You can imagine gravity as a soft sheet draped over the world, sagging slightly where mass is clustered, smoothing out where mass is thin. If you could visualize the gravity around a mountain, you'd see a subtle bulge, a region where the sheet rises and bends before leveling out again. Even now, as you lie in bed, gravity beneath you is shaped by the density of the crust below your city, the minerals in the soil, and the long-forgotten geology under your home. We walk across the planet feeling as though gravity is the same everywhere, but it isn't. The world's gravity is patchy, textured, alive. Mountain ranges act as enormous anchors on the landscape, affecting the flow of air, water, and even the movement of satellites overhead. NASA's GRACE mission, 2 satellites chasing each other around Earth, detects these tiny gravitational variations as they speed across the sky. When they pass over a mountain, their separation shifts slightly. That shift is gravity whispering a secret. There is something massive beneath you, and you, here now, lying in the quiet, are part of this vast, interconnected system. Gravity isn't just holding you, it's shaping the world beneath you in ways most people never realize. The ground you walk on, the ocean tides, the air currents, the tectonic plates, all of them respond to these subtle variations. Gravity is the language the Earth speaks with itself. As you rest, let yourself imagine that subtle pull, the mountains rising in the distance, the deep layers of rock beneath your feet, the shifting weight of the planet, all participating in a silent conversation of mass and curvature. You may not feel it directly, but your body is part of that landscape, held gently by the same force that tugs on mountains, oceans, and stars. Tonight, gravity is simple for you, a soft downward pull, cradling your body, guiding your breath. But beneath that simplicity lies a world of hidden structure, mountains bending gravity, gravity shaping the earth, and the earth shaping you. You're sinking deeper now, your breath steady, your shoulders softening as the quiet wraps gently around you. And as your body grows heavier against the mattress, you're ready to explore one of gravity's most calming yet mysterious effects. The tides, a phenomenon that feels like it belongs only to the ocean, yet touches every inch of the earth, including the ground beneath you at this very moment. When you think of tides, you might picture waves rolling onto a beach, rising and falling with the moon's gentle pull. But tides are much more than water shifting. They're the earth itself breathing, expanding, stretching, relaxing, under the influence of gravity. Every coastline in the world feels it. Every ocean feels it. And surprisingly, so does the solid ground under your home. Right now, as you're lying still, the entire planet is swelling and shrinking by tiny amounts. The Earth's crust, which feels solid, unwavering, permanent, actually moves up and down by nearly 30 centimeters in some regions as the moon passes overhead. You can't feel it. No one can. But this constant, global heartbeat is happening all the time, like the world exhaling and inhaling under a cosmic rhythm millions of years older than humanity. The moon is the main dancer in this quiet motion. It pulls the oceans toward it, creating a bulge on the side of Earth facing the moon. But it also pulls the Earth itself, creating a second bulge on the opposite side. So the Earth isn't covered by one tide, but two. And as the planet rotates through these bulges, you get high tide, low tide, high tide again, a steady, endless rhythm we live inside without realizing it. If you could float above the Earth right now, looking down in a peaceful, dreamlike state, you'd see the oceans stretching toward the moon like a soft, shimmering oval. Not a violent motion, more like a gentle shifting, as if the sea itself were reaching upward in its sleep. But here's the little-known detail, the one that feels strangely intimate. Tides don't just move water, they move you. Your body is pulled upward slightly when the moon is overhead. Your bones lift by a fraction of a millimeter. The ground beneath you rises too. Even lakes experience tides, though they're too small to notice. And the atmosphere, the air you're breathing right now, has its own tides, rising and falling, compressing and expanding with the moon's rhythm. If you could sense these changes with your skin, it would feel like a soft, slow rocking, the world gently adjusting itself while you rest on its surface. Scientists call this the solid Earth tide, and it's one of the planet's most subtle mysteries. Instruments as sensitive as lasers and atomic clocks detect it easily. but your body just relaxes into it without ever noticing, as if you're participating in a ritual older than life itself. Yet, even in this peaceful rhythm, there's a debate that quietly stirs among geophysicists. Are tides primarily about gravity or inertia? Some scientists argue that the moon pulls upward, creating the tidal bulges. Others insist that the Earth, spinning beneath those bulges, drags the oceans into motion, and the pull is actually just an effect of rotation and momentum. A third group proposes that both explanations are incomplete, that tides emerge from a deeper interplay between gravitational gradients, orbital mechanics, and Earth's internal elasticity. It's a debate with no simple resolution, because tides are both gravity and motion, both pull and response. The world is never still, and tides are the proof. But the story gets even stranger. The tides are slowly pushing the moon away from Earth. Every year, the moon drifts about 3.8 centimeters farther into space. It's tiny, but over millions of years, this drift adds up. Long ago, the moon was closer, the tides were stronger, and Earth spun faster. A day was shorter. Sunrise and sunset came more quickly. The world moved at a different tempo. Tonight, as you lie here drifting towards sleep, the moon is quietly changing your world. Not just with tides, but with time itself. One day, not tomorrow or next year, but far in the future, the Earth and moon will turn in perfect synchrony, facing each other forever. The tides will grow weaker, the world will slow, nights will lengthen, and though none of us will be here to see it, the thought itself is calming. Everything changes, even the dance between gravity and the moon. If you picture the ocean now, not as water, but as a living layer draped over the planet, you can almost feel its weight shifting. Imagine standing at the shoreline at dawn, watching the water pull away from the sand as the moon moves overhead. That slow retreat is gravity sculpting the world in real time. Every grain of sand, every wave, every tide pool reflect a cosmic choreography written billions of years ago. What's even more extraordinary is that tides shape the planet on long time scales. They slow Earth's rotation. They help mix ocean water, distributing heat and nutrients across the globe. Without tides, some scientists believe complex life might never have evolved. Tides create intertidal zones, places where water comes and goes, exposing shorelines twice a day. These zones act as natural laboratories for evolution, where life learns to adapt, crawl, breathe, and eventually step onto land. You're lying in bed, feeling small, quiet, safe. Yet you are here because tides once shaped the earliest life forms into something capable of walking, thinking, breathing, dreaming. The moon's soft tug on ancient oceans was the first whisper of the world that would eventually hold you. And now, as you breathe, your chest rising and falling in its own rhythm, you're participating in another kind of tide, a personal one. Your breath ebbs and flows like waves on a beach. Your thoughts drift in and out like ripples on water. The world moves around you in cycles, gravitational, biological, cosmic, and you're floating in the middle of all of them. Tonight, the tides touch everything. The oceans, the earth, the air, your body, your breath, your thoughts. A gentle pull, a soft release. A rhythm older than timekeeping, older than language, older than memory. Gravity, in its quiet way, rocks the world to sleep. You're resting deeper now, your breath slow and steady, your body sinking into the comfort beneath you. And as the world around you grows quieter, you begin to sense something even more delicate, something almost ghostly in its subtlety. The gravity shadow, a phenomenon so faint, so easily overlooked, that most people never hear of it. Yet it's happening all around you, even in this calm moment, shaping the way gravity reaches you from the earth below. Imagine gravity not as a single pull, but as countless tiny tugs from every piece of mass inside the earth. Every rock, every grain of soil, every atom beneath your feet contributing a minuscule part to the force you feel. Gravity is the combined whisper of billions of silent voices, all pulling in the same general direction. But here's the strange part. Not all of those whispers reach you. Some get blocked. Some get muffled. Some are absorbed by the layers of matter between you and the center of the earth. That soft weakening, that tiny shielding effect, is something scientists call gravitational shadowing. The idea is simple but beautifully counterintuitive. Mass can block gravity, just a little. The Earth's own layers reduce the gravitational pull from deeper layers. It's not enough for you to feel physically, but it's enough for sensitive instruments to detect. Enough that it quietly affects how gravity changes from place to place. Close your eyes for a moment and imagine a small cavern beneath you. If you were standing right above it, you would weigh slightly less. Not because the Earth's gravity suddenly weakened, but because there is less mass directly under your feet. There is a tiny hole in the chorus of gravitational voices singing upward toward you. Where there should be rock adding its pull, there is empty air. And so, you feel ever so slightly lighter. This is the gravity shadow. Places where mass is missing or redistributed, causing a subtle dimming of gravitational strength. Geophysicists use this phenomenon to map the hidden world beneath the surface. Lost caverns or deposits, underground rivers, even ancient volcanic chambers long cooled and buried. They look for shadows, for places where gravity dips like soft, invisible dimples scattered across the planet. And here's something even stranger. Your body experiences its own gravitational shadow. The mass of your chest blocks a tiny fraction of Earth's gravitational pull from reaching your back. Your legs shadow your feet. Your arms shadow your ribcage. These differences are absurdly small, too tiny for you to feel in any way, but real nonetheless. In a sense, your body gently dims the gravity that flows through it. Now imagine something bigger. Picture a mountain, a vast, towering mass of rock casting a gravitational shadow behind it. When sensitive instruments stand on one side of the mountain, the pull of gravity shifts. Some of the Earth's gravity is blocked. Some is added. Some bends around the mountain in delicate, almost poetic curves. You can imagine the field lines, invisible strands, wrapping over the peak like the flow of wind, dipping behind it, swirling downstream before smoothing out again. As you lie here, you're wrapped in the same kind of invisible patterns. Gravity isn't just pulling downward in a straight line. It's adjusting itself according to what lies beneath and around you. If you could feel these changes, it would be like sensing ripples in a pond, slight dips and rises, soft gradients beneath the constant downward pull. But this phenomenon doesn't come without debate. Some scientists argue that gravitational shadowing doesn't truly exist in the classical sense. Gravity, they say, isn't like light. It doesn't get blocked, absorbed, or dimmed by matter. Instead, mass simply contributes to the gravitational field. It doesn't act as an obstacle. According to this view, the reason you weigh less above a cavern isn't because deeper mass is blocked, but because it simply isn't there. Others push back, pointing to experiments and measurements showing gradients that behave as if gravity is partially shielded, as if the mass between 2 points changes the gravitational relationship between them. A minority of researchers even speculate that gravity could experience a form of attenuation, a kind of drift or diffusion through matter, especially dense matter like lead or tungsten. No one has proven this definitively, and the debate remains unresolved. One of those scientific puzzles that quietly sits at the edge of our understanding. If you let your imagination wander, you might see gravity flowing like water through the earth. In places where rock is dense, the flow slows. In places where caverns open, the flow thins. And in places where heavy mountains rise, the flow concentrates. It's not literally water, of course, but thinking of it that way helps you sense how dynamic the gravitational landscape truly is. What makes all of this even more soothing to think about is how seamlessly your body synchronizes with these variations. You don't have to adjust. You don't have to correct anything. Your muscles, your balance, your inner ear, they all adapt automatically to the gravitational environment beneath you. Even as gravity subtly shifts with the moon, the mountains, the tides, the hidden cavities underground, your body remains at ease, as if it has always known how to respond. And in a way it has. Every living creature on Earth evolved inside this imperfect, rippled, textured gravitational field. Birds feel it differently than whales. Trees anchor themselves into the ground under its pull. Even tiny insects rely on it for balance as they crawl. Your body, too, has been shaped by these variations, by the tilt of the Earth, by the density of the crust, by the moon's slow drifting tide, by the invisible shadows cast by mountains and valleys. Right now, as you rest, the Earth's gravity is passing through you like a quiet, continuous wave. It flows up through the soles of your feet, through your bones, through the soft weight of your chest. And though parts of your own body shield that flow ever so slightly, the effect is peaceful, a gentle reminder that you're part of a structure much larger than yourself. You're not just lying on the earth. You're participating in the way gravity shapes the world. You're feeling its soft imprint, not with your senses, but through your being. Tonight, the gravity shadow isn't something to detect or measure. It's something to rest inside, a quiet dimming, a soft whisper of the world beneath you, a reminder that even the smallest forces can carry the deepest calm. You're drifting even deeper now, the quiet settling around you like a soft blanket. Your breath is slow, your limbs heavy, and in this calm state, you're ready to explore something astronauts know intimately. Something so surreal, so quietly transformative, that it reveals just how deeply gravity shapes the human body, the mysteries of microgravity. You've felt gravity your entire life. It's the anchor behind every step you take, every time you sit, lie down, rise. But imagine, just for a moment, the world suddenly letting go of you. Not violently, not in a fall, but in a soft, liberating drift. Your body lifts with no effort. Your arms hover beside you. Your legs float upward. Your organs shift gently inside your chest, as if rising into a warm, weightless pool. This is the world astronauts enter whenever they leave Earth's embrace. And what happens to them, to their bodies, their senses, even their minds, is far stranger than most people ever realize. Inside the International Space Station, astronauts float like slow-moving lanterns. They push off a wall with a fingertip and drift for meters. They curl into sleeping bags and zip themselves to the wall so they don't drift away while they dream. They let food hover in front of them and guide it into their mouths. Every movement is fluid. Every gesture is slow. It looks peaceful, almost meditative. But microgravity is mischievous. It plays with the human body in subtle, unexpected ways. The most immediate change happens within minutes. Fluids rise. On Earth, gravity pulls your blood downward, filling your legs, grounding your circulation. But in microgravity, there is no down, and so the fluids drift upward into your chest and head. Astronauts describe the feeling as having a cold, invisible tide slowly rising inside them. Their faces puff, their cheeks swell, their eyes become slightly more prominent, their sinuses clog, they sound congested for weeks. Your body, if it were in space right now, would become a little balloon of itself, rounder, softer, almost childlike. But the effects run deeper. Within days, your bones begin to weaken. Bone density drops. Muscles shrink, not because astronauts fail to use them, but because gravity is gone. The invisible gym you grew up in suddenly closed. On Earth, even lying still requires muscle activity. Your posture, your balance, your internal support systems are always buzzing quietly. But in microgravity, none of those systems are needed. Your spine elongates. You become a few centimeters taller. Your joints decompress. You float comfortably, effortlessly, but at a cost. Even the heart changes. It no longer has to fight gravity to pump blood upward, so it becomes rounder, slightly smaller. The entire circulation system shifts into a softer, almost dreamlike mode. What's even more fascinating is how the inner ear reacts. Your sense of balance, your ability to know which way is up or down, collapses completely. Astronauts wake up confused, unsure if they're floating sideways, upside down, or perfectly upright. In the first few days, many experience space sickness, dizziness, nausea, disorientation. Their brains are trying to process a world without a gravitational reference point, without a stable floor. And yet, somewhere between the first week and the second, the brain begins to adapt. It creates a new internal map, a new understanding of movement, a new default orientation. Up and down stop existing. Your mind learns to live without them. And suddenly, drifting in 3 dimensions becomes as normal as walking. But amid all these changes, one little known detail stands out. Microgravity affects vision in mysterious ways. Some astronauts return to Earth with permanently altered eyesight. Their eyes flatten slightly. Their retinas shift. Their optic nerves swell. No one fully understands why. The leading theory is that the fluid shift increases pressure in the skull, but other scientists argue that the shape of the eye changes because it no longer needs to fight gravity. Still others propose that microgravity affects cellular structure itself. It's an ongoing debate, one that touches a deeper mystery. Is gravity necessary for biological integrity? Is life, the kind of life that evolves on planets, fundamentally dependent on a constant downward pull? Some researchers say yes. They argue that everything from bone density to cell division evolved under Earth's gravity and cannot function normally without it. Others insist the body can adapt completely given enough time, that microgravity is simply unfamiliar, not harmful. A few believe gravity affects biological processes in ways we haven't even discovered yet, perhaps influencing how proteins fold, how genes express themselves, or how fluids transport nutrients at the cellular level. As you lie here tonight, safely held by Earth's pull, you're experiencing the opposite of microgravity. Your fluids are exactly where your body expects them to be. Your bones feel the familiar compressive force that keeps them strong. Your heart pumps with a rhythm tuned to 1G, the quiet weight of life beneath you. Your inner ear knows exactly which way the world is oriented. Everything is where it should be. Gravity has shaped you for every moment of your existence. But imagine drifting now. Your body floating, your arms weightless, your thoughts untethered. No pressure on your back, no sense of up or down, just the gentle feeling of being suspended in nothingness. It will be beautiful, peaceful, liberating, but also alien, as though your body were learning itself again. And yet, here in the quiet of your room, you have something astronauts miss deeply: the comfort of returning to gravity at the end of the day, the familiar embrace of weight, the grounding sensation of sinking into a bed, the gentle reassurance of knowing you are held. Gravity, in its quiet way, gives you rest. Microgravity gives you wonder. And tonight, you're floating somewhere between the two, imagining the drift while feeling the warmth of the earth beneath you. You're drifting further into the softness of the night now, your thoughts slowing to a gentle drift, your breath deep and unhurried. And as you settle even more comfortably into gravity's embrace, we turn to one of the strangest truths in physics, a truth so counterintuitive that it feels almost impossible. Gravity is the weakest force in the universe. Right now, it's holding you to the Earth, shaping the oceans, guiding the planets, sculpting galaxies, and governing the motion of stars. It feels powerful, inescapable, ever-present. And yet, compared to the other forces of nature, gravity is unbelievably, absurdly, almost embarrassingly weak. Imagine holding a paperclip in your hand. Now, imagine lifting that paperclip using nothing but a small refrigerator magnet. That tiny magnet, something you could toss across the room with 2 fingers, is defeating the gravitational pull of the entire Earth. One small magnet against a planet billions of trillions of tons in mass. And the magnet wins easily. How can a force so weak rule the structure of the universe? That question sits at the center of one of the greatest mysteries in modern physics. You might imagine shrinking yourself down to the size of an atom, a world where protons, neutrons, and electrons dance in strange quantum patterns. At that scale, gravity barely exists. The electromagnetic force between 2 charged particles is stronger than gravity by a factor of 1,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000. It's a number so large that the human brain can't fully picture it. If gravity tried to influence an atom, it would be drowned out by the nuclear and electromagnetic forces instantly. This extreme difference, this colossal imbalance, is what scientists call the hierarchy problem, and it's one of the biggest unsolved puzzles in physics. Why is gravity so weak? Why is it so gentle? Why can it shape galaxies but barely touch atoms? Some researchers believe gravity isn't weak at all, that it only looks weak because most of it is leaking into hidden dimensions beyond our perception. They propose that space-time might be larger than what we see, and gravity spreads through those unseen dimensions like light shining through a sheet of fabric. What we feel on Earth is only the faint residue, the echo, the leftover fraction that doesn't escape. Others argue that gravity might not be a fundamental force at all. Instead, it might be something that emerges from deeper, more subtle phenomena, something like the temperature of a gas, which only appears when billions of particles act together. If that's true, gravity could be the surface effect of a much deeper reality. And then there are those who believe gravity is simply geometry, the bending of space-time caused by mass. In this view, gravity isn't really a force. It's just the shape of the universe gently guiding everything along curved paths. The weakness of gravity, according to this idea, is simply a reflection of how gently space-time bends around everyday objects. This debate, geometry, emergence, or hidden dimensions, remains unresolved. And each side has beautiful arguments, elegant theories, and passionate defenders. But none of them can yet explain why you feel gravity as gently as you do right now. As you lie here, the Earth is pulling on every atom in your body. But the pull is so soft, so consistent, so familiar that you don't even notice it. It feels like the natural state of things, the world holding you, the ground supporting you, your breath deepening under the steady weight of being alive. But consider this. If you were on a neutron star, an object made of collapsed atoms so dense that a teaspoon would weigh billions of tons, gravity would crush you instantly. It would squeeze your body into a sheet of atoms in less than a heartbeat. On a neutron star, gravity isn't weak at all. It's overwhelming, violent, absolute. The same force that feels like a whisper here becomes a roar there. Gravity is a shapeshifter, gentle on Earth, ferocious in the cosmos, almost non-existent inside an atom. It has no single personality. It adapts to the environment, scaling across unimaginable ranges of strength, depending on mass, density, and curvature. And yet, in all its forms, gravity performs the same quiet role. It holds things together. It sets boundaries. It gives structure. It creates worlds. You feel it now in the simplest way. Your body rests heavier against the bed. Your breathing grows slower. Your thoughts ease. Gravity anchors you, not just physically but emotionally, a quiet reminder that you are supported. For all its weakness, gravity shapes your existence. For all its gentleness, it sculpts galaxies. For all its subtlety, it guides time itself. And tonight, it's doing the smallest, sweetest task of all, holding you steady as you drift towards sleep. You're drifting even deeper now, your breath warm and slow, your body sinking into a soft, effortless stillness. And as your thoughts begin to float like dust in a sunbeam, you're ready to explore one of the most beautiful, mind-bending ideas in all of physics, the curved fabric of space-time. You felt gravity your whole life as a downward pull, the gentle anchoring force that keeps your feet on the ground, your bed beneath you, your world steady. But according to Einstein, and according to every experiment that has confirmed his ideas since, gravity isn't really a force at all. It's a curve, a shape, a distortion in the invisible fabric of the universe. And right now, as you lie here in the quiet, you're resting inside that curve. Imagine the Earth not as a sphere floating in emptiness, but as a heavy ball resting on an enormous, flexible sheet stretched out in every direction. The ball sinks into the sheet, bending it gently. And if you place another small ball nearby, it rolls inward, not because the first ball is pulling it, but because the sheet itself is curved. That sheet, that smooth, invisible expanse, is space-time. You're lying on it. You're made of it. You move through it with every heartbeat. And the curve of space-time beneath you is what you feel as gravity. This idea alone is enough to change the way you see the world, because it means that you're not being pulled downward by an invisible force. You're simply following the shape of the universe beneath you. You are resting at the bottom of a gentle cosmic valley molded by the Earth's mass. Now imagine that valley more closely. It isn't rigid. It isn't permanent. It's alive, elastic, responsive. It stretches when the moon passes overhead. It ripples when two people walk across the room. It shifts subtly with the movement of air, the flow of oceans, the spinning of the Earth's core. And on cosmic scales, it ripples with the orbit of planets, the collapse of stars, the rotation of black holes. You're not lying on a motionless landscape. You're lying on a dynamic, shifting river of geometry. But here's one of the strangest, least known details. Space-time curves not only around mass, but inside mass. Deep beneath your body, under the floor, under the crust, all the way to the center of the Earth, space-time curves inward more and more, like a spiral deepening toward the core. Every layer of rock contributes to the shape. Every atom adds a tiny bit of curve. Earth is not just heavy, it's sculpting the universe around it. Now, imagine removing the Earth entirely. Instantly, space-time would relax. The curvature beneath you would flatten. Gravity would vanish. Time itself would change pace. It's strange to realize how dependent you are on this shape. How gravity is less like something acting on you, and more like the environment you exist inside. Like a fish in water, you don't feel it unless it changes. And that brings us to a curious scientific debate. Is space-time a real, physical object, or just a mathematical tool? Some physicists argue that space-time is as real as the air you breathe, a tangible medium that bends, stretches, ripples, and interacts with matter. Others insist it isn't a substance at all, but a geometric language we use to describe relationships. A few push even further, proposing that space-time might emerge from quantum entanglement, that the universe's fabric is woven from connections between particles, like a network of threads stitching reality together. No one fully agrees. No one fully knows. Yet the evidence suggests that the universe behaves exactly as if space-time is something real, something flexible, something sculpted by mass. Right now, if you could step outside yourself and watch your body from above, you'd see it nestled in a slight dip in space-time's surface. Not a steep one, just a soft, planet-sized indentation. The Earth curves space-time downwards. The moon curls it slightly to the side. Distant stars make their own tiny impressions. All these curves add together into the gentle, invisible landscape that you are lying in. And this landscape guides you effortlessly. It keeps your feet pressed to the floor. It keeps your breath flowing with a familiar rhythm. It keeps the world feeling stable, predictable, comfortable. But this curved fabric doesn't only direct you. It directs everything. Light curves through it. Planets glide along it. Stars orbit through its valleys like marbles rolling in vast cosmic bowls. Even time itself flows differently depending on how steep the curvature is. Imagine a clock placed deep inside a massive crater on Earth, ticking ever so slightly slower than a clock on a high mountain. That's space-time's influence, stretching time in some places, relaxing it in others. If you could watch the solar system from a perspective outside space-time, you wouldn't see planets being pulled by the sun. You'd see them sliding through curved geometry, following paths determined not by a force, but by the very shape of the cosmos. And here you are, feeling the simplest, most peaceful version of that truth. You're resting in a slight dip in space-time. You're floating in geometry. Gravity isn't pulling you down. You're just lying still on a curved surface. Let yourself sink into that curve now. Let your body feel heavier. Let your breath fall into its steady rhythm. You are safe inside this invisible valley. A valley carved by Earth, shaped by mass, whispered into existence by the universe itself. Tonight, space-time is your cradle, and you are resting in the shape of the cosmos. You're drifting deeper now, your breath soft and unhurried, your mind floating in that quiet space between thought and sleep. And as the world around you fades into a gentle hush, you're ready to explore one of the most delicate, mesmerizing consequences of gravity's touch. Gravitational lensing, the way mass bends light. reshaping the universe like a cosmic magnifying glass. Right now, as you lie in the dark, light seems simple. It moves in straight lines. It fills your room softly. It bounces off walls and objects and travels effortlessly into your eyes. But in the vastness of space, light behaves differently. Its path is not straight. It curves. It bends. It wraps itself around stars and galaxies as if the universe were made of glass. Imagine traveling far beyond Earth, floating in the quiet cold of deep space. Ahead of you is a massive galaxy, a swirling, luminous island of billions of stars. Behind that galaxy lies something faint, a distant quasar, shining from billions of years in the past. The quasar's light travels across unimaginable distances, heading straight toward you. But before it reaches your eyes, it encounters the galaxy in front of it. And in that moment, something extraordinary happens. The galaxy curves space-time around itself, and the quasar's light bends. Not a simple bend, not a gentle curve, but a sweeping, elegant distortion, like the ripples formed when sunlight passes through water. The quasar appears stretched, magnified, duplicated, even formed into a perfect bright ring circling the galaxy. These rings, called Einstein rings, are some of the most breathtaking sights in astronomy. Perfect circles of light created not by optics, not by glass, but by gravity. In that moment, you see the universe acting as its own telescope. What's surreal is that this phenomenon isn't rare. It's happening everywhere. The cosmos is full of massive objects, clusters of galaxies, dark matter halos, black holes, bending and sculpting light like invisible hands. The images captured by telescopes such as JWST and Hubble sometimes show distant galaxies warped into delicate arcs and spirals. They look like strokes of paint, but each stroke is light being pulled along the curves of space-time. And here's the quiet wonder. Gravitational lensing allows us to see things we would never otherwise see. Some of the oldest galaxies ever discovered were found only because their light was magnified by objects in front of them. Without lensing, they'd be too faint, too distant, too ancient to detect. Gravity doesn't just shape the universe. It reveals it. It shows us worlds behind worlds, layers of cosmic depth hidden from ordinary sight. Even now, as you lie still, billions of beams of ancient light are curving through space before they ever reach Earth. You're unaware of it, but the night sky above you is filled with distorted images. Galaxies stretched into arcs, stars shifted slightly from their true positions, cosmic illusions created by gravity gently tugging at light. And yet, this leads to a debate that scientists still wrestle with. Is gravitational lensing caused purely by visible mass, or by something else? When astronomers first measured the lensing effect around galaxies, they were stunned. There wasn't enough visible matter, stars, dust, gas, to account for the strength of the curvature. Light was bending more than it should. Something unseen was amplifying gravity's effect. This mystery is what gave birth to the idea of dark matter, an invisible substance that outweighs ordinary matter 5 to 1, shaping the universe through gravity alone. According to this view, the gravitational lenses we see are mostly created not by galaxies themselves, but by enormous cocoons of dark matter surrounding them like invisible scaffolding. But not everyone agrees. Some physicists argue that maybe gravity itself needs to be modified, that the equations we use work perfectly on Earth but break down on cosmic scales. Maybe gravity behaves differently in the vast emptiness between galaxies. Maybe space-time curves more strongly than expected. Maybe the bending of light reveals flaws in our assumptions rather than hidden mass. Others propose even stranger ideas. Perhaps gravity emerges from quantum entanglement. Perhaps spacetime is granular at microscopic scales. Perhaps dark matter is made of exotic particles that barely interact with our world. Debate continues. Observations deepen. The mystery remains. But there is something you can feel right now, something grounding and comforting. Every beam of starlight that has ever touched your eyes has been shaped by gravity. Not just the gravity of Earth or the Sun, but the gravity of everything it passed along the way. Ancient superclusters, invisible dark matter halos, galaxies long gone, stars that exploded before humans even existed. Light carries the fingerprints of the universe. As you drift here, calm, warm, safe, you're lying at the bottom of a cosmic river of curved light. Every photon that reaches your eyes at night has been bent, slowed, softened, or magnified by the geometry of space-time. You are seeing the universe not directly, but through the lens of gravity itself. Imagine that now. The night sky as a vast, shimmering tapestry woven through curves. Every star slightly shifted. Every galaxy slightly magnified. Every cosmic object wrapped in a halo of distorted light. And you, resting beneath it, quiet and still, part of the same soft curvature. Tonight, gravity isn't just pulling you downward. It's sculpting the light of the universe. It's shaping what you can see, what you can know, what you can imagine. A gentle bend, a soft distortion, a cosmic whisper carried on beams of ancient light. You're sinking even more deeply into the quiet now, your breath steady, your body warming softly under the blanket of night. And as the world fades into a gentle hum, you're ready to step toward one of the most extreme, awe-inspiring regions shaped by gravity. The realm of black holes, where gravity is so intense that the rules of time, space, and even light itself begin to unravel. Close your eyes for a moment and imagine drifting through deep space. The stars are faint pinpoints in the distance. The darkness feels endless, silent, delicate. And then, ahead of you, you see it, a region where the stars behind it distort, stretch, swirl, as though the universe is being pulled toward an invisible drain. The space around it glows with a halo of curved light, photons trapped in a final orbit, circling the void before being consumed. This is a black hole, and you are approaching the edge of the most powerful gravitational well in the universe. What's strange and beautifully surprising is that if you drifted closer, you wouldn't necessarily feel anything at first. Black holes don't pull you faster than normal stars until you get very close. From far away, a black hole's gravity feels almost gentle. You could orbit one the way the Earth orbits the Sun. You could float past it without noticing anything strange. It's only when you approach the event horizon, the boundary beyond which nothing can return, that gravity begins to behave in ways that defy everyday intuition. Imagine hovering just outside that boundary. Time begins to stretch. Seconds become longer. Your heartbeat slows relative to the universe behind you. From your perspective, everything feels normal. Your breath steady, your vision clear, your thoughts untroubled. But to an observer watching from a safe distance, you're slowing, dimming, fading. They see your clocks ticking slower. Light from your body shifts toward red, stretched by gravity. Your final moments outside the black hole would appear frozen in time. Inside your experience, nothing special happens at all. You simply drift. This gentle contradiction, ordinary from within, extraordinary from outside, is one of the strangest consequences of gravity's influence on time. Even stranger is the tidal effect. When you're far from a black hole, gravity pulls evenly across your body. But as you approach the horizon, the difference in gravitational force between your head and your feet increases dramatically. In a small black hole, this difference would stretch you into a long, thin strand, a process scientists nicknamed, with dark humor, spaghettification. But around a supermassive black hole, the kind that lives in the center of galaxies, the gradient is surprisingly gentle near the horizon. You could drift across the boundary without feeling stretched or compressed. Inside, the rules change, but not abruptly. You'd simply continue falling deeper and deeper into the curved fabric until the singularity, a point of infinite density, eventually claims you. And that singularity remains one of the greatest mysteries in physics. Some scientists argue it's truly a point, a location where gravity becomes infinite, space-time collapses, and the laws of the universe break down. Others believe the singularity is not a point at all, but a region of extreme but finite density hidden behind quantum effects. A few propose that singularities don't exist, that they're mathematical artifacts that vanish once we discover a full quantum theory of gravity. Debate rages. Evidence is scarce. Answers remain hidden behind the event horizon. But the strangest mystery of all is this: black holes may not simply destroy, they may create. Some theories suggest that the singularity at the center of a black hole could be a gateway, a bridge to another region of space-time, another universe, or another part of this one. These ideas are speculative, but beautiful. They hint that black holes might be engines of creation, not annihilation. Others propose that information swallowed by a black hole is never truly lost. It's encoded on the event horizon's surface, a holographic shell containing every detail of everything that ever fell inside. If that's true, then black holes are cosmic libraries, storing information in the strangest possible way. But even the idea of information loss is controversial. Stephen Hawking believed for decades that black holes destroy information, violating the fundamental principles of physics. Later, he admitted he may have been wrong and proposed that information is preserved, subtly encoded in the radiation black holes emit as they slowly evaporate over trillions of years. Even now, physicists remain divided. Some say information escapes. Some say it's hidden. Some say it's transformed. No one knows for certain. As you lie here tonight, these questions might feel impossibly large, like trying to grasp the shape of the universe with your fingertips. But you don't need to understand every detail. The soothing truth is simply this: gravity has many faces. The gentle pull holding you to your bed tonight, and the overwhelming pull that traps light itself, are the same phenomenon, same equations, same curvature, same whisper in space-time. One gentle, one fierce, both part of the same cosmic story. You, resting quietly in this moment, are connected to that story. Your body is shaped by the same physics that governs black holes. Your atoms dance in the same geometry that bends starlight around the cosmos. Your breath rises and falls in rhythm with the same force that binds galaxies. And tonight, as your eyes grow heavier and the world softens around you, you can let that thought cradle you. Gravity holds everything, from the tiniest grain of dust to the most powerful black holes, in a single, elegant embrace. You're drifting deeper now, your mind softening into a calm, quiet place where thoughts float like lanterns on a still lake. And as sleep begins to brush at the edges of your awareness, you're ready to explore something exquisitely gentle yet unimaginably powerful. Gravitational waves, the faint ripples in space-time that pass through you every moment. even now, without you ever noticing. Imagine lying perfectly still, just as you are, while the universe around you quivers ever so slightly. Not enough to feel, not enough to move a single grain of dust in your room, but enough to stretch and compress space itself. Enough to alter the distance between atoms by a fraction of a fraction of a fraction of a proton. These waves are the softest vibrations in the cosmos, echoes of events so massive and violent that they shake the fabric of reality. And yet, here you are, feeling nothing. The universe is rippling around you, and you rest peacefully in its quiet pulse. Let's drift back in time for a moment. 1.3 billion years. Somewhere in a distant galaxy, two black holes were spiraling toward each other. They had been dancing this deadly, intimate dance for millions of years. With every orbit, they churned space-time like water circling drain, and as their orbit tightened, the ripples they produced grew stronger, faster, louder in the language of gravity. Eventually, in the final milliseconds, they collided, merging into a single, larger black hole. That collision released more energy than every star in the observable universe combined, but not in light, not in heat, not in radiation. It released energy as gravitational waves. Those waves traveled across the universe, stretching and shrinking space itself. They passed countless galaxies, countless stars, countless planets. They moved through interstellar dust clouds. They rippled through dark matter halos. They washed through nebulae, star clusters, spiral arms, and eventually, they reached Earth. They passed through you, through your body, through the bed you're lying on, through everything that exists. You didn't feel them. No one felt them. But a pair of incredibly sensitive detectors, long tunnels filled with lasers, recorded the faintest whisper, space stretching here, compressing there. A signal so delicate that it changed the length of a 4-kilometer tunnel by less than 1,000th of a proton's diameter. This was the first direct detection of gravitational waves. A ripple in reality, a whisper from the ancient universe. And it passed straight through the Earth as softly as a dream. Even now, at this very moment, gravitational waves are passing through you. Waves from merging black holes, waves from colliding neutron stars, waves from supernova explosions, waves from the earliest moments after the Big Bang, ripples from the universe's birth. The room around you is not perfectly still. The space you're in is gently flexing, like the surface of a calm pond under a breeze too soft to feel. And yet, no matter how delicate gravitational waves are, they have profound effects. When two neutron stars collide, the waves they produce don't just ripple space-time, they forge heavy elements. Gold, platinum, uranium, the rare metals in your electronics, even the gold in jewelry. All of it comes from these collisions. Gravitational waves are part of the cosmic alchemy that built the universe and everything in your life. This leads to one of the quiet debates in modern physics. Are gravitational waves a fundamental feature of space-time, or a consequence of deeper quantum processes? Some scientists argue that gravitational waves confirm Einstein's view. Space-time is a smooth, continuous fabric capable of vibrating like a drum. Others suggest that these waves might reveal a deeper granularity, that space-time might be composed of tiny quantum units that jiggle, flex, and shimmer. A few even propose that gravitational waves might expose flaws in general relativity, showing that our equations break down under extreme conditions. And yet, no matter the debate, one truth remains beautifully certain. Gravitational waves reveal that the universe is not silent. It hums, it sings, It vibrates with the echoes of cosmic events. As you lie here, gently breathing, you're part of that cosmic music. You're lying in a place where space-time itself subtly stretches and contracts. Your atoms adjust, your molecules shift, and yet the motion is so soft, so incredibly gentle, that you experience it as peace. Tonight, gravity isn't just holding you down. It's carrying the faintest memories of distant galaxies. It's imprinting the quiet notes of cosmic collisions onto the space you inhabit. It's letting you rest in a universe that is alive, dynamic, ever-changing, even in silence. Let your body sink a little deeper now. Let your breath lengthen. Let your thoughts drift. The universe is rippling softly around you, and you are drifting with it. Calm, steady, safe. You're drifting into an even deeper calm now. Your breath slow and steady. Your body warm and heavy as the world fades into a gentle blur. And as you soften into this quiet space, you're ready to explore one of the strangest puzzles in all of gravity. The missing mass of the universe. The invisible presence scientists call dark matter. It's a quiet mystery, a gravitational ghost that shapes galaxies, bends light, and holds the cosmos together, even though no one has ever seen it. Imagine yourself floating in the vast emptiness of space, gazing at a magnificent spiral galaxy turning slowly before you. Its arms sweep outward like glowing ribbons, filled with billions of stars. It rotates with a kind of cosmic grace, steady, serene, hypnotic. And yet, hidden beneath this elegant motion is a paradox so profound that it shook astronomy to its core. When scientists measured how fast stars orbit the centers of galaxies, they expected the outer stars to move more slowly, just like planets in our solar system, where Mercury orbits fast and Neptune crawls along at a gentle pace. But galaxies didn't behave that way. The outer stars were moving far too fast, so fast that the galaxies should have torn themselves apart long ago. Something was wrong. The visible matter, the stars, gas, dust, wasn't enough to hold them together. Gravity wasn't strong enough. The math didn't add up, unless there was something unseen adding its gravitational pull. Something invisible but massive. Something that didn't emit light, didn't absorb it, didn't reflect it. Something that passed through stars, planets, even your body, without interacting. That invisible mass became known as dark matter. You can imagine it now. A vast halo of unseen material surrounding every galaxy, like a silent, transparent cocoon. It doesn't shine, it doesn't glow, but its gravity holds everything in place. From the swirling arms of galaxies to the clusters of galaxies drifting through deep space. Right now, as you lie in your room, dark matter is passing through you, trillions of particles each second, without touching, without leaving a trace. You feel nothing. It feels nothing, yet its gravity shapes the universe around you. It's peaceful, in a way, a cosmic presence you'll never sense, but one that keeps the world stable. But here's where the story grows even stranger. No one knows what dark matter actually is. Some scientists believe it's made of particles, exotic, elusive, barely interacting. Others think it's something entirely different, a field, a fluid, a new form of mass that doesn't play by the usual rules. And a few argue that maybe dark matter doesn't exist at all, that our understanding of gravity is incomplete. This leads to a quiet, beautiful debate in physics. Is the universe full of invisible matter, or does gravity behave differently on cosmic scales? One camp insists dark matter is real. It explains the rotation of galaxies, the gravitational lensing we observe, the structure of the early universe. Another camp says we're misinterpreting gravity itself, that the equations we use on Earth fail in the vast emptiness between galaxies. And then there are the dreamers, the theorists who imagine something even stranger. What if dark matter is connected to hidden dimensions? What if it's the shadow of matter in another universe? What if it's the imprint of quantum fluctuations woven into space-time? No one knows. No telescope has seen dark matter. No experiment has caught it. No particle collider has revealed its signature. All we see is its effect. All we feel is its gravity. Imagine now drifting through a galaxy rich with dark matter. You wouldn't see it, but you would feel its presence in the motions of stars, in the rotation of spiral arms, in the way gravity curves space-time around you. It would be like floating inside a gentle, unseen cloud. One that doesn't touch your skin, doesn't make a sound, but holds the entire structure in place. It's strangely comforting to realize that the universe is full of hidden support systems. Just as the Earth holds you tonight, dark matter holds galaxies, clusters, and cosmic web filaments, the vast interconnected structure stretching across billions of light years. Picture that web now, a network of glowing threads connecting galaxies like beads on cosmic strings. Between those threads lies dark matter, quietly shaping everything, guiding everything, sculpting the universe like a silent architect. And you are lying in one tiny corner of that vast cosmic structure, safe, warm, grounded by the gravity of your planet, drifting gently into the deeper darkness of night. Dark matter doesn't make sound. It doesn't shine. It doesn't disturb your rest. But it is part of the same gravity that holds you, the same geometry that cradles you, the same cosmic story you are woven into. Tonight, the unseen universe feels calm. Mysterious, yes, but gentle. Hidden but steady. Distant, yet connected to you through gravity's quiet pull. Let that thought soften you. Let your breath settle. Let the unseen world around you feel like a blanket of silence. You are resting in a universe full of secrets, and all of them are holding you safely in place. You're drifting so deeply now that the edges of your awareness feel soft, almost blurred, like distant hills fading into evening mist. Your breath is long and unhurried. Your body is heavy, warm, supported. And in this final stretch of your journey tonight, we rise gently above all the details, all the strange physics, all the invisible subtleties of gravity, to see the bigger picture, a universe held together by a single, gentle force. Imagine yourself floating far above Earth, not in the cold vacuum of space, but in a dreamlike quiet, a place where you can see everything without feeling exposed to the vastness. Below you, the planet glows softly, wrapped in blue oceans and drifting white clouds. You can see the curve of the horizon, smooth and calm. You can see the faint shimmer of city lights. Everything feels fragile, and at the same time, deeply rooted. Gravity holds it all together, not forcefully, not fiercely, but with a steady, patient pull. As you drift higher in your imagination, you see the moon circling Earth, held by gravity's invisible tether. You see the planets orbiting the sun, each tracing its own quiet arc through space-time. And beyond them, the stars form clusters, and those clusters form galaxies, all gently gathered by gravity's touch. It's as if the entire universe is breathing in unison. A slow, cosmic inhale and exhale, a dance guided by geometry, mass, and motion. You begin to sense how interconnected everything is. The atoms in your body were forged in stars whose collapse required gravity. The warmth you feel right now comes from chemical reactions shaped by the distribution of matter on Earth. The rhythm of your breath is synced, indirectly, but undeniably, with the cosmic cycles gravity orchestrates. Right now, without even trying, you are participating in a structure billions of years old. Every moment of your life has unfolded inside this gentle curvature of space-time. You've never stepped outside it. You've never been without it. You've never even paused to question it, because gravity is so reliable, so constant, that it feels like the most natural thing in the world. But this quiet inevitability hides a deeper beauty. Gravity is the architect of everything large and the enabler of everything small. It forms stars, shapes galaxies, guides planets, creates tides, bends time, sculpts trajectories, illuminates the past through gravitational lensing, carries the echoes of cosmic collisions as gravitational waves. And all of that, every cosmic structure, every shimmering star, every swirling nebula, emerges from the same gentle pull that you feel as weight on your body tonight. There's something deeply peaceful in that realization. The universe doesn't hold itself together through violence or strain. It holds itself together through a constant, quiet attraction, a pull that asks for nothing but presence. As you drift deeper, you can imagine watching a galaxy from above, a spiral of countless worlds turning slowly, gracefully, effortlessly. Gravity choreographs that dance, coordinating billions of stars as if they were grains of luminous sand swirling in a soft cosmic breeze. Zoom in further, and you see stars pulling their planets close, keeping them warm enough for life. Zoom in again, and you see oceans rising and falling, tides forming, atmospheres swirling, trees growing, creatures breathing, all guided by gravity, the faintest of the fundamental forces, yet the one that shapes the very stage on which life unfolds. There's a quiet irony to this. The weakest force in the universe is the one that gives the universe structure, and you're lying here tonight, cradled softly within that structure. Your body is gently pressed into the mattress. Your breath sinks deeper into your chest. Your muscles loosen. Your mind drifts. Gravity is helping you sleep, not by pulling you down, but by offering you consistency, a sense of place, of steadiness, of orientation. It tells your body where you are. It tells your senses which way is down. It gives your nervous system permission to relax. Even your dreams, in a way, depend on gravity's quiet stability. And when you wake tomorrow, gravity will still be there. The same gentle curve in space-time, the same invisible anchor, the same quiet presence that has followed you through every moment of your life. The universe may be full of mysteries, dark matter, hidden dimensions, the behavior of gravity at quantum scales. But the simplest truth is also the most comforting. Gravity holds you, just as it holds the planets, the stars, the galaxies, the cosmic web, and everything that exists. Tonight, as you settle deeper into rest, you are part of a universe held together by a single, soft embrace. A universe where every falling leaf, every orbiting moon, every drifting particle of stardust moves to the same ancient rhythm. And you, lying here in the stillness, are gently, quietly, beautifully woven into that rhythm. Now, let everything slow even further, as if your thoughts are dissolving into a warm, quiet mist. Your breath becomes softer, your eyelids heavier, and the world seems to gently dim around the edges. Even the idea of gravity itself fades into something comforting, Not a force, not a theory, but a sense of being held, supported, anchored in the softest possible way. Imagine your body floating just above the surface you're lying on, not weightless, not drifting, but suspended in a perfect equilibrium. The pull of the earth meets the softness of your bed, and you rest right in the middle, safe and still. The space around you grows quieter. Thoughts become slower. Sensations become warmer, deeper, calmer. Let the images soften now. The galaxies swirling like brushstrokes in a sleeping sky. The stars drifting peacefully across curved spacetime. The oceans rising and falling in ancient rhythms. The earth humming with the gentle tides of the moon. The universe whispering through gravitational waves. All of it fades into a distant, peaceful glow. Your breath sinks into a steady, soothing pattern. In soft and warm, out long and easy. Each exhale feels like releasing another layer of the day. Each inhale feels like drifting further into the quiet. The world is gentle now. Your mind is calm. Your body is heavy and relaxed. Gravity holds you, and you allow yourself to surrender completely. Let the last of your thoughts drift away like tiny stars dissolving into the night. You are safe. You are warm. You are held.